Hey guys, welcome to our video for this week. I don't think we'll have one for Thursday, so this is going to be our only video for the week. We're going to talk a little bit about what can go wrong in surveys and studies, and then talk a little bit about using studies and things effectively. It'll be interesting. We'll see also a couple of famous studies that are out there. I think you'll see some that are a little bit shocking, perhaps. All right. So a couple of things. First of all, when we talk about studies and stuff, what could go wrong? There's a few things that can go wrong. We already talked about bias and how we really want to avoid bias, and so our sampling procedures that result in bias could be problematic. Like convenient sampling. So we try to use, stratification or something to help understand what that bias is like. But there may be some things that can happen that aren't really sampling errors, and we need to know what those are too. Undercoverage is a great example of a non-sampling error. It has to do with when the people you're sampling from aren't really representative of the entire population. So you've missed a segment of the population, for example. And that's called undercoverage. The famous example I have for that was back when Barack Obama was first elected president, he had to go through a primary. And his primary challenger that he was up against was Hillary Clinton. And Hillary Clinton had won the Iowa caucus there in the 2008 cycle. And then we were going on to New Hampshire. And at the time, the way they did the polling was they called people on the phone. They called on their home phones. And what they didn't do was call cell phones. And an interesting phenomenon was happening at that time that some people were getting rid of their landlines. They're like, why do I even need this landline anymore? And so when they called, they missed a large chunk of the population. Now, who was it that wasn't having a landline anymore? Well, it turns out that was primarily young people. And President Obama was very popular with the younger voter in that time. And so a lot of our polling in New Hampshire showed Clinton was going to win. What actually ended up happening was Obama won that. And then he went on quite a roll from that point on to get the presidential or the nomination. And when we look back at it afterwards to the pollsters and the statisticians, they noticed that that there was a problem with the sampling. We had an undercoverage. By not calling cell phones, they missed out on a bunch of likely Democratic voters because they didn't have landlines anymore. So we had the undercoverage. We missed the folks without landlines. Non-response is one where people just refuse to be surveyed. And I think if we think back to the 2016 presidential election, we have a pretty good idea of what happens when a large segment of the population refuses to participate or can't be contacted in the study. The polling data leading into the 2016 election seemed to indicate a pretty strong support for Hillary Clinton, the Democratic nominee. President Trump was losing, and there didn't seem to be any pathway that he would have to the White House. But what we didn't realize, or what people didn't realize at the time in the polling, was that there was this, they called them like the silent Trump voter or the hidden Trump voter, because they refused to be surveyed. And these largely rural voters came out in force, though, and swung the election, obviously, because we have President Trump. And he was able to win the election, and it seemed to be that there was a large amount of non-response. And that bias was important, because the people who did respond tended to respond in favor of Hillary Clinton. People who weren't responding, a key fact about them was they were voting for President Trump. Well, then candidate Trump, now President Trump. So that response bias that we get can be problematic, and it can come from a variety of places. The last one, word questions, the wording in the questions, that can be that can be influencing. That could influence somebody's uh, answer to your survey question. The way you wrote the wording of the question can also do that. So question wording bias, especially in sample surveys, can be a real problem. So those are some of the things that can go wrong with surveys and sampling. Um, now, what about in experiments, larger experiments, and how do we use those wisely? Well, experiments, oh, here we go. Um, we want to establish a causation, but we have to really be careful of the difference between correlation and causation. And it is challenging to establish causation, especially in a lot of studies that we really want to establish causation. And that'll get into the third point there, the data ethics. Because sometimes, even though we'd love to do cause and effect, we can't due to ethical concerns. And we'll talk about the scope of inference in this section too. So the scope of inference is basically what can we say based on the design of this study? What kind of inferences am I allowed to make? Okay. A well-designed experiment can usually result in a cause and effect, but there might be limitations in terms of the population that it would describe. Okay. Observational studies, because we don't randomly assign people to groups, usually can't establish some sort of cause and effect, but we could randomly select our participants, so that could pertain to a larger population. There's a great two-way table here, as you can see, and I really like this two-way table because it allows you to see, based on what you did at the beginning of your study, what kind of inference would you be able to make at the end. So for example, were the individuals randomly selected? If that is a yes, then you will be able to make inference about the larger population. If that's a no, well, then the only people you can infer anything about are the people who were part of your study, okay, because they weren't randomly selected. On the other side, the other axis here, were they randomly assigned to groups? Okay, did they get randomly assigned to like control groups and the various treatment groups? If that's a yes, then you will be able to make an inference about cause and effect. Did our explanatory variable cause the effect we see in the response variable? But if you didn't randomly assign them to groups, then you can't really make a cause and effect inference. Okay. So thinking back to Dr. Fauci's testimony from last week, what kind of study did we have? We had a retrospective cohort study, right? So were the people randomly selected? No, these were people that were already in the hospital. Okay. Were they randomly assigned into groups? No, they weren't. Okay. We didn't have any random assignment because we did it retrospectively. So you can see why Dr. Fauci said this was a flawed study. It's a no on both. There's not really a whole lot of inference we can make based on that study. The cause and effect establishment is tricky, though, even in a well-designed study, because there have been a few experiments over the years that have gone through that have seemed to establish cause and effect, but then in reality that inference proved to be false. So I've got one in particular that is pretty famous. So if you look at the back of your car, if you drive a car that was built any time in the last 30 years, when you step on the brake, there's actually 3 lights on the back that light up. There's the 2 regular taillights, and there should be one up higher in the middle of the car. Up higher, some of them have it on the back window, some of them just have it on the trunk lid. But there should be a 3rd brake light. Okay, and that 3rd brake light wasn't always there. It was back in, oh gosh, I want to say the 1980s. They did a study where they took a fleet of rental cars, and it was like 5,000 rental cars, and they wired in a 3rd brake light in the back window that shone back there. And they were trying to see if maybe people just weren't paying attention to those brake lights, but if the third one lit up, would it help prevent rear end collisions? And they randomly assigned the cars and they put them all over the country. And so they had random selection, they had random assignment, the well-designed study, and sure enough, the cars with that third brake light had a very significant reduction in rear-end collisions. Okay, and so the National Highway Transportation Board, the Safety Board, the NTSB, got a hold of this study, and they said, "Wow, look at this!" And they went to Congress, and said, "Look at this! Look what this data shows. Like, if we put this third brake light in the window, we're going to have a really great reduction in rear-end collisions." So they did. They passed a law that every car made after this date will have to have that third brake light, and they did that. And you know what happened? The proportion or the amount of rear-end collisions stayed relatively unchanged. It may have dipped initially, but it's back up to basically where it was before. And that's because the study lacked some realism. Okay? Because what happens after a while is people get used to new stimuli. At first it was like, whoa, cool, look at that, there's a third brake light that lit up. That was weird, you know. But eventually people are like, oh, yeah, that's just another brake light, so I don't need to pay attention to that. And that's what we mean by lacking realism. There's lots of examples of where things might lack realism. The other thing here is it says it might not be ethical to do an experiment. Yeah, and that's where we start to really run into some problems when we want to establish cause and effect. Does smoking cause cancer? Okay. It says so on the pack of cigarettes. If you buy a pack of cigarettes, it says Surgery General, smoking causes cancer. But did they do a statistical study to establish that? Like actual cause and effect? Because remember, if I flip back to the previous slide, it'll tell us that the only way to get cause and effect is if we randomly assign people to groups. Okay, that's like me saying to our class, like, okay, if you're on the first page of this Zoom meeting, you are never ever going to be allowed to smoke cigarettes. Okay, and if you're on the second page of this, you are now a 3-pack a day smoker, and I'm going to make sure that you get your 3 packs of cigarettes every day, and you have to smoke all 60 of those cigarettes by the end of the day, and you have to do that for the rest of your life, which might not be as long as the other group because we're going to see if you can get cancer. Is there an ethical concern there? Yeah, you bet. Pretty dramatic one, right? Because we're trying to see if people get cancer, and that can be fatal. And so your study shouldn't actually kill people. So that's that ethical concern. As we start to establish causation, it's a challenge because, might not be realistic, or we might not be able to really do that study because it's not nice. And you have an ethics board to make sure you're not doing anything that's not nice. So the association is strong for smoking and cancer, but we can't actually say it causes cancer without doing the study. Okay. Well, you would think that, but it turns out that after a while, you are allowed to establish that causation. And here's the risk factors, or I'm sorry, not the risk factors, the factors that allow us to make that cause and effect statement, even though we haven't actually done the experiment. So, data ethics. Okay. Yeah, so ethics are a big concern of ours, and when we're doing this, there's almost always a review board. Everybody who's in the study has to have informed consent, and the individual data has to be kept confidential. And it's that second bullet point that I wanted to make sure, are we allowed to lie to people? Sometimes yes, we can. They can agree to be part of our study, and we can kind of tell them what it's about, but we don't have to be 100% truthful. So sometimes I know it feels like, oh, that doesn't seem very ethical, but yeah, you can play tricks on them, but only to a point. And so there's a very famous study, the Milgram experiment, that really took this to an extreme. And so in the Milgram experiment, I actually pulled it up because it's just a shocking experiment in terms of how messed up it was. Uh, and so let me, uh, it was very deceptive. Um, so the Milgram, okay, the Milgram experiment. It's quite literally a shocking experiment because Milgram was very interested in the Nuremberg war criminal trials after World War II because they put all of these Nazis on trial, especially the ones that worked in the concentration camps like Auschwitz and such, and put them on trial for murder, like mass murder. And the defense that they gave was time and time again, I was just following orders. Okay, I was ordered to do that. And what he was interested in was like, how far would somebody go if they were ordered to do something by a person of authority? And so he designed a study to do it, and I'll just explain it to you really quickly before we finish. So he had people that volunteered to be part of the study, and they were brought in to the study, and there was another group that were volunteers, but they're actually co-conspirators with the experimenters. And what happened was the volunteers, they mingled a little bit beforehand, so they met each other, and the co-conspirators who were actors were also in there. And then they would randomly select a pair, and then that pair would get randomly assigned. One person would be responding to questions. The other person would go with an experimenter into a room. And the person who was answering questions was always not actually randomly selected. That was always the co-conspirator. So they're in on it. Okay. And the poor person who goes with the other person into the control room has no idea what's about to happen. Okay. And what they did, there's a video here on this website. I'm not going to watch the video. I think. So what they did was the learner, as they called it, went into the room, and they were attached to an electric shock generator. So like an electric chair or something like that, where they could be administered a shock. And then the teacher goes with the experimenter into the other room. Now, the learner that is actually in on it, they're not actually going to get electrocuted. They're just going to pretend that they're getting electrocuted. And the person who's the teacher that goes with the experimenter is given a panel, and I think they had a picture of it here. And what they said they were doing was they were going to see the effect of how an electric shock could impact the learning on the part of the learner in the other room. And so the teacher went into the room, and there's a person of authority there, a guy looking very official, white lab coat, clipboard, all that kind of stuff, and they would instruct them on what to do. And so they would read a question, and if the learner got it wrong, then the experimenter would administer a shock. And you can see here they are hooking him up to the shock generator. Okay, and after they would get the question wrong, here's the setup right here. They would administer a shock, and then they would increase the voltage. And it was amazing to see what would happen. That the teacher, in this case, the person in the room here, would give the shock to the student to the point where they wouldn't even hear anything from the other room, but they would still keep shocking them. They used these phrases when they would not, like if the teacher was like, I don't want to do this, I can't do this, I can't, I just can't. They would say, the first time they'd say, okay, please continue. And then, if they did it again, they'd say, this experiment requires you to continue. It is absolutely essential. You have no other choice but to continue. And it was very interesting to see that, that yes, the teachers would, by and large, continue on to the highest voltage. And here what you have is 65% of the participants continue to the highest level, 450 volts, which would be fatal. And all the participants went to 300 volts. So it seemed to provide pretty compelling evidence that even though we think that, you wouldn't necessarily intentionally hurt somebody like that or kill them when instructed to by a person of authority, yeah, these people did. Okay. And it's important to know that this study has been replicated, and the results are consistent. Now, there are a few individuals who would just say, no, I'm not doing this at all. And they would get up and they would never get involved. But a lot of them would. And he summed it up in the article, The Perils of Obedience. And yeah, this is a study that you could never get away with now. This was the 1960s. The ethical questions behind this study are pretty profound. And I don't think you would be able to get the Milgram experiment past any sort of review board in today's modern statistical world. So, all right. So yeah, the data ethics. We already looked at this slide. So did those people actually give consent to be part of this study like this? And the answer is no, they did not. They did not think they were signing up for this. So there we go, guys. That's how to use studies wisely and some things that can go wrong. We'll talk more about this in class either Monday or Tuesday, depending on which day I have you in class. And like I said, this will be our only video this week. The rest of the week is spent reviewing, and then your assessment from Chapter 4 is a week from either Monday or Tuesday, depending on which section you're in. If you're in second period Monday, if you're in fifth or sixth, it'll be Tuesday. All right. Thank you guys so much, and I will see you in class.